These kind of things we have seen till now. The next thing what we have to see is nothing but systems. Okay. Suppose if somebody is asking what is a system, what it is doing, what is the meaning of system. In layman terms, I can say like this. Suppose it is a combination of physical components which is going to give you some proper output. It has to give some proper output. Then we can call it is a system. So any combination of elements which has to give some proper output. Suppose let's say take a ceiling fan. Suppose if you take a fan which is rotating. Now it is having so many components like an induction motor, it is having a capacitor, it is having blades, everything. If you switch it on, then it is going to rotate and it is going to give you some proper output which is nothing but airflow. Now I can call this ceiling fan as a system. I can call this ceiling fan as a system, as simple as that. In more fashion way, I can say system is going to do processing on the signal. That means it can convert the signal into more desired form. That's what the signal, what we can say system is doing, or we can say this is called as signal processing. Understood? So what the system will do? Finally, it will do signal processing. I hope you understood. Okay. So that's about the definition part. It is not much important for us. Let's see now the next one, which is nothing but classification of system. How can we classify the system in different ways? The first and foremost way we can say a linear and a non-linear systems. Linear, first classification, linear and non-linear systems. Linear and non-linear systems. Okay, listen carefully. A system is said to be linear when it satisfies two properties or it obeys two principles. What are those principles? Every linear system has to obey two principles, and those two principles are, one is nothing but additivity, and another one is nothing but homogeneity. So when a system obeys these two principles, then we can say the system is linear. If it is not obeying any one of the property, still we can say it is a non-linear system. So let's say if a system is obeying additivity principle but not the homogeneity principle, still it is non-linear. If it is obeying, let's say, homogeneity principle but not additivity, still it is non-linear. To say it is a linear, it has to obey both the properties. Understood? Let's see how it is going to be additivity. Additivity means what? Additivity. Suppose if I take a system, let's say x of t is the input and y of t is the output. Let's take a signal x1 of t. For this, it will produce y1 of t. Let's say, assume. Let's take another signal which is x2 of t. Then it is going to produce another output y2 of t. What if I combinedly take these two signals? That means x1 of t plus x2 of t. The sum of the two signals if I take, then what is the output you are expecting? That means if a system obeys the additivity principle, then the output should be in this form. That means this is what we are expecting. It may be, it may not be. This must be y1 of t plus y2 of t. Actual output may be different or may be same. If actual output is also the same way, which is nothing but y1 of t plus y2 of t, then we can say the system is obeying additivity principle. Otherwise, it is not obeying it. I hope you understood. That means if I add the input signals, then output must be get added. Then we can say the system is obeying the additivity principle. Otherwise, it is not. Okay. Next, homogeneity principle. How we can say homogeneity principle? Homogeneity means, suppose if I take a system, if input is x of t, output is y of t, output is y of t. Now, what if I multiply input with some constant k, x of t? That means if input is multiplied with some constant k, then what kind of output you are expecting? If the system is obeying homogeneity principle, then we are expecting the output must be in the form which is also ky of t, ky of t. That means if the system obeys homogeneity principle, then if I say the input is multiplied with some constant k, then the output is also multiplied with the same constant k. Then that is nothing but the homogeneity principle. Here we have to remember one thing. What the k? K can be real or complex. Real or complex. Some people will think only it is a real number. No, it can be a complex number also. Anything can be k. Okay. So this is about the homogeneity and additivity. Okay. Take it. Okay. Let's see some examples how we can decide whether the system is linear or not. I will do one problem completely, then I will tell you a shortcut how to find whether the system is linear or not. Okay. Let's see. Let's take an example. Y of t is equal to x of t square. Okay. Now try to understand what is the functionality of the system. What is the functionality of the system means, suppose if input is x of t, we are getting output is x square of t. That means what the system is doing on the input signal so that I can get the output. So simply I can say the system functionality is squaring the input. Whatever the input you have giving, it doesn't matter, it will simply square it and give us output. Okay. So that means if I take a system if the input is x of t, the output is y of t, which is x of t square. Simply squaring the input, that's what the meaning of it. Now let's see. First I am checking additivity principle. Additivity principle, whether it is satisfying additivity or not. Okay. Let's give x1 of t as the input. Then what is the output y1 of t? So whatever the input, it doesn't matter, it will square the input. So it is going to be x1 of t square. That's it. Suppose if I change the input to x2 of t, then what is the corresponding output? Let's call it is y2 of t, which is nothing but x2 of t square. x2 of t square. Now, if I combine them, x1 of t plus x2 of t. Now what the system will do, actually whatever the input is given, it has to be square it. That means the actual output what I am getting is nothing but square of the input. That means x1 of t plus x2 of t square whole square. That's what the actual output we are getting. But what we are expecting, the expected output is in the form of y1 of t plus y2 of t. y1 of t plus y2 of t. That means it is x1 of t square plus x2 of t square. If you observe carefully, this is the actual output which is given by the system, and this is the expected output if the system is obeying the additivity principle. So by comparing them, actual output is not equal to expected output. Actual output is not equal to expected output. So from this I can say the system is not obeying additivity principle. So not obeying additivity. So directly I can say from this the system is non-linear. But still I want to check for homogeneity also. Let's say checking for homogeneity. Here itself we can say it is a non-linear. I told you any one of the property fails, then we can say the system is non-linear. So additivity is already failed. I can say the system is non-linear. But still I want to check the homogeneity. How we can check the homogeneity? Homogeneity. Let's say if x of t is the input, then y of t is equal to x of t square. X of t square. What if the input is k y of t? Sorry, k x of t. What if the input is k x of t? I told you the functionality of the system is simply squaring the input. Then the actual output is k x of t whole square. K x of t square. That means it is nothing but k square x of t square. But what is the expected output if it is obeying the homogeneity principle? If the input is multiplied with k, output is also multiplied with the same constant k, ky of t. Then this is k x square of t. So if I see the actual output is k square x square of t, whereas expected output is k x square of t, both are not equal. So the system is not obeying homogeneity principle. The actual output is not equal to expected output. So it is not obeying homogeneity. So I can decide if it is not obeying both homogeneity and additivity principle, the system is non-linear. The system is non-linear. Non-linear. So this is the way we can say whether the system is non-linear or not. But in general, we don't do this much of exhaust process. Let's say simple way how we can check additivity, how we can check homogeneity, if they are satisfied or not. Listen carefully. To check additivity principle, we require actual output and expected output. If we compare them, we can understand whether it is satisfying additivity or not. Okay. To find actual output in the additivity, simply replace x with x1 plus x2. Replace x with x1 plus x2. Then you can get this one directly. Next, to find the expected output, which is nothing but y1 of t plus y2 of t. So by comparing them, we can say whether it is a satisfying additivity or not. Next, to check for homogeneity, we require actual output and expected output. To find actual output, simply replace x with kx. Replace x with kx. Then you can get actual output. To get expected output, simply ky of t, multiply k to y of t. You can get expected output. Compare them, whether it is satisfying or not. Understood? First take down this. So I am writing those points in a simple manner how we can do this. So to check for additivity, so in additivity, to check for additivity principle whether it is satisfied or not, what I am doing, listen, to find actual output, replace x with x1 plus x2, and expected output y of t is equal to y1 of t plus, so instead of y of t, maybe it is a discrete time case also, I am writing y expected is equal to y1 plus y2. Now see here, for this example only I am doing it. Additivity, what is the actual output? Replace x with x1 plus x2, then it is going to be x1 of t plus x2 of t whole square. Next, expected output is equal to y1 of t plus y2 of t. y1 of t is nothing but x1 of t square, y2 of t is nothing but x2 of t square. So by comparing them, they are not equal. I hope you understood how to calculate actual output and expected output. In the similar manner, in homogeneity, what we have to do? In homogeneity, to find actual output, replace x with kx, and expected output is equal to simply ky. Now try for this one, y of t is equal to x of t square. The actual output is simply replace x with kx, so kx of t whole square. Then what is the expected output, which is nothing but ky of t. So whatever y of t is there, that has to be multiplied with, so it is kx of t square. In this way we can directly find these 4 steps, 1 1 2 1 2 4 steps. In these 4 steps we can decide whether it is a linear system or not. Okay, take it. Okay. Let's see some more examples. Try this one. Y of t is equal to 5x of t. So if I try this one, let's see. Additivity I am checking. Y actual output is equal to 5 into x1 of t plus x2 of t. That means simply I am replacing x1 with x1 plus x2. Next, expected output is equal to y1 of t plus y2 of t, which is 5x1 of t plus 5x2 of t. Both are same, because if you take 5 inside the bracket, which is nothing but 5x1 of t, 5x2 of t, so I can say yes, it is satisfying additivity principle. It is satisfying additivity. Additivity is okay. Next, homogeneity I am checking. To find actual output, replace x with kx, 5 into kx of t, 5 into kx of t. Then what is the expected output? Ky of t, ky of t, which is k into 5x of t. If you observe carefully, both are same, 5k or k5, it doesn't make any difference. So I can say it is satisfying homogeneity also. Homogeneity also satisfied. So I can say both the properties are satisfied. The system is linear. The system is linear. Next, y of t is equal to 5x of t plus 3. Plus 3. In 2018, this question was given. We have to see which one is a non-linear system. So this is a non-linear system. How it is going to be non-linear? Let's check it out. Actual output for additivity principle. Wherever x is there, that has to be replaced with x1 of t plus x2 of t plus 3. Now, what is the expected output? y1 of t plus y2 of t. So y1 of t means if x1 of t is the input, which is nothing but 5 x1 of t plus 3. What is y2 of t? 5 x2 of t plus 3. So here let's see, 5 x1 of t, 5 x2 of t, it is there, plus 3. But here plus 3, which is nothing but 6. So here it is not satisfying additivity principle. Additivity does not satisfy. Next, if I go with the homogeneity, the actual output is equal to wherever x is there, that has to be replaced with kx, 5 kx of t plus 3, kx of t plus 3. Now, what is the expected output? If input is multiplied with k, output is also multiplied with k, ky of t, which is k into 5x of t plus 3. So here k5, 5kx of t, 5kx of t, but here it is 3, but here it is 3k. So both are not equal. So again, homogeneity is not satisfied. Homogeneity is not satisfied. So I can say the system is non-linear. Take it. Non-linear. Make it fast. We have to see so many examples. Y of t is equal to e power x of t. Again, it is a non-linear system. Check by yourself. I am not doing it. It is a non-linear system. Next, y of n is equal to log x of n. This is also a non-linear system. Check them. I am not doing this. You can understand. Next, if I say y of n is equal to x of cos n, x of cos n, then this is going to be a linear system. Then this is going to be, or we can say in general, y of t is equal to x of, better, y of t is equal to x of cos t. Now, this is going to be a linear system. I will prove it. This is a linear system. Linear. How, sir? Please first try to understand what is the functionality of the system. What do you mean by functionality of the system? Suppose if input is x of t, output is x of cos t. Input is x of t, output is x of cos t. What the function it is done? Simply I can say t got to be replaced with cos t. Whatever x of t is there, in that t has to be replaced with cos t. That's what the meaning of it. So let's say actual output for additivity principle, which is x1 of cos t plus x2 of cos t. In the similar manner, expected output is also the same, which is y1 of t plus y2 of t, which is again same way x1 of cos t plus x2 of cos t. So it is satisfied the additivity principle. It satisfied additivity principle. Next, homogeneity principle. The actual output is x is replaced with kx of cos t. Then what is the expected output? Ky of t, which is x of cos t. Both are same again. So it satisfied homogeneity also. So I can say it satisfied additivity as well as homogeneity. The system is linear. Linear. Take it simultaneously. Okay, running notes here. Take, because it won't take much time and you already know these things. Next, if I take y of n is equal to x of n plus x of n minus 3, still it is going to be a linear system. You can do it. It's a linear system. It's not a big deal. You can do it. Next, y of n is equal to x of n into x of n minus 1. Then this is going to be a nonlinear system. I will prove it now. Nonlinear. How, sir? Let's check it out. Actual output in the additivity principle, wherever x is there, that has to be replaced with x1 of t plus x1 of n in this case plus x2 of n multiplied with x1 of n minus 1 plus x2 of n minus 1. x2 of n minus 1. So this is the actual output we got. But what is the expected output? Which is y1 of n plus y2 of n. y1 of n, which is nothing but x1 of n, x1 of n minus 1 plus x2 of n into x2 of n minus 1. Are they same? No, definitely not. They are not same. We are having extra term x1, x2, n minus 1, x2 of n, x1, n minus 1. These two terms are extra for us. So I can say it is not satisfying additivity. Additivity does not satisfy. Next, in the same way, it is not going to satisfy homogeneity also. Let's check it out. Actual output for homogeneity, which is wherever x is there, that has to be replaced with kx of n multiplied with kx of n minus 1. So finally, this is nothing but k square x of n into x of n minus 1. Whereas expected output is nothing but ky of n. So simply multiply the output with the k. So it is kx of n into x of n minus 1. If you observe carefully, this is k square, this is k, both are not equal. So I can say this is not satisfying homogeneity also. So the system is non-linear. The system is non-linear. Okay, take it first. Let's see next example. Y of t is equal to mod x of t. Mod x of t. Is it linear or non-linear? It is definitely non-linear. It's definitely non-linear. How? Let's say, if I go to find out additivity, actual output is nothing but wherever x is there, that has to be replaced with x1 plus x2. What is the expected output? Y1 of t plus y2 of t, which is mod x1 of t plus mod x2 of t. If you observe, both are not equal. For that, let's take some examples. You can understand why they are not equal. Let's say 3 minus 5. What is the total modulus? Which is nothing but 2. If I take mod 3 plus mod minus 5, which is nothing but 8. Both are not equal. So it is not satisfying additivity principle. Additivity is not satisfied. Additivity not satisfied. Next, suppose if I take a homogeneity, that is also not going to be satisfied. Actual output, wherever kx is there, that has to be replaced with kx of t. Then expected output is ky of t. Output is also multiplied with k, so it is nothing but k mod x of t. So if I expand this, it is mod k mod x of t. Both are not same. Both are not same. So it is not satisfying because it is mod k, here it is k. Homogeneity also not satisfied. So the system is non-linear. Non-linear. It is something like, you have to remember, it is a straight line passing through origin, then we can say the system is linear. Straight line passing through origin. Straight line passing through origin. Then the system is linear. That means, let's say, y is equal to mx. This is a linear system. Whereas y is equal to mx plus c, which is not a linear system. Why? It is a straight line, I can agree with that, but it is not passing through origin because it is having y-intercept. Suppose it may look like this, but whereas this one looks exactly this one. Straight line passing through origin, but it is not, it is a straight line, I can okay with that, but it is not passing through origin. That's why it is a non-linear system. Whereas if you take y is equal to mod x, in the previous case, y is equal to mod x, how it look like? It is a V-shaped curve, everybody knows it. V-shaped curve, it is not a straight line passing through origin, so this is also non-linear system. I hope you understood. Okay. This is a linear, this is a non-linear, and this is also non-linear. Only y is equal to mx, that is a straight line passing through origin, is linear. y of t is equal to x of t conjugate. So many people think that it is a linear system, but it is not. It is a non-linear system. Okay. First of all, try to understand. I am just going with a mathematical analysis only. Actual output in the additivity principle, x is replaced with x1 plus x2. x1 of t plus x2 of t whole conjugate. Next, what is the expected output? That is y1 of t plus y2 of t, which is x1 of t conjugate plus x2 of t conjugate. Now, observe carefully. So many people think that it is not satisfying additivity principle. No, it is satisfying additivity principle. Why? If you bring this conjugate inside, this is going to be x1 of t conjugate plus x2 of t conjugate. So both are same. So I can say it is satisfying additivity principle. But still we have to check the homogeneity also. It is satisfying additivity principle. Let's check for the homogeneity. In the homogeneity, what is the actual output? Which is x is replaced with kx. Next, what is the expected output? Which is ky of t, which is kx of t conjugate. So by observing them, they are not equal. Why? This can be expanded like this: k conjugate x of t conjugate. So I told you k can be a real or complex. So k conjugate and k both are not equal if it is a complex number. If it is a real number, it's okay. But we don't have to see which is a real only. It can be a complex number also. So it is not satisfying homogeneity. It is not satisfying homogeneity. So from this information, it is not satisfying homogeneity. So I can say it is a non-linear system. It is a non-linear system. Take it. So whenever you see conjugate, that indicates the system is non-linear system.